In this unit, we are going to look at level of significance, degree of freedom, and decision making. Then we are going to calculate t-test and chi-square. The purpose of testing a hypothesis is to determine the probability that it is supported by facts. Therefore, hypothesis testing is really a systematic way to test claims or ideas about a group or population. The hypothesis to be tested is usually stated in null hypothesis, which is represented by the symbol H0, and alternate hypothesis, which is represented by symbol H1. The null hypothesis is a statement about a population parameter, such as the population mean, that is assumed to be true, while the alternate hypothesis is a statement that directly contradicts a null hypothesis by stating that the actual value of a population parameter is less than or greater than or not equal to the value stated in the null hypothesis. Level of significance for a text. The level of a significance or significance level is referred to as a criterion of judgment upon which a decision is made regarding the value stated in the null hypothesis. And in most researches in education, two alpha levels are used, and these are 5% with 0.05 and 1% with 0.01. If you decide to use 5% in a study, the implication is that if the study is replicated 100 times, the same outcome will occur 95 out of 100 times. And if you decide to use 1%, the implication is that if the study is replicated 100 times, the same outcome is sure 99 out of the 100 times. The degree of freedom. This is the number of observations which are free to vary when certain restrictions have been placed on the data being considered. Making a decision in any research study. So we use the value of the test statistic to make a decision about the null hypothesis. And this decision is based on the probability of obtaining a sample mean, given that the value stated in the null hypothesis is true. So if the probability of obtaining a sample mean is less than 5% when the null hypothesis is true, then the decision is to reject the null hypothesis. And if the probability of obtaining a sample mean is greater than 5% when the null hypothesis is true, then the decision is to retain the null hypothesis. We need to know that we can use critical or table value and the calculated value to take decision. So if the calculated value is greater than the table value, we can also reject the null hypothesis. But if the calculated value is less than the table value, we also retain the null hypothesis. And when we are taking decision in any research study, we have to be very careful so that we don't make errors. So when the null hypothesis is true and you reject the hypothesis, we have committed type 1 error. So when the null hypothesis is false and then we accept or we retain the hypothesis, then we have committed type 2 error. The t-test is used to determine whether difference of two means is significant or not. Let's solve a t-test using the given example. So in this example, we have to find out whether mean performance of male and female student mathematics are significantly different. So to solve this, we are going to use the formula t equals to mean 1 minus mean 2 all over square root of a big bracket is open, n minus 1 in the bracket s square, so plus n2 minus 1 in bracket s2 square, then you close the bracket all over n1 plus n2 minus 2 then you have 1 over n1 plus 1 over n2. So from the table given, we have our mean 1 to be 24.92, mean 2 to be 16.69, standard deviation 1 to be 5.89, standard deviation 2 to be 5.53. Then our n1 is 65, while our n2 is 60. What we do now to do is to substitute in the formula. So if you substitute that, you get 24.92 minus 16.69 all over square root of 65 minus 1 in the bracket, then 5.89 square plus 60 minus 1 in the bracket, 5.53 square all over 65 plus 60 minus 2, and then we have 1 over 65 plus 1 over 60. So if you calculate that now, you get, if you take away 16.69 from 24.92, that will give us 8.29. Then 65 minus 1 will give us 64, while 5.89 square will give us 34.69, plus 60 minus 1 will give us 59, times 5.53 square will give us 30.58 all over 60 plus 62, 65 plus 60 minus 2 give us 123. Then we have 1 over 65 give us 0.015, plus 1 over 60 will give us 0.017. So we have 8.23 all over, so 60 times 34.69 plus 59 times 30.58. If you do that, we are going to get 4024.38, then all over 123. So if you had 0.015 plus 0.017, you are going to get 0.032. So if you solve that now, we have 8.23 all over. So if you divide 4024.38 divided by 123, that gives us 32.72, then times 0.032. So 8.23 divided by, so if you multiply 32.72 times 0.032, it's going to give us 1.07. So if you now do for that, if you find the square root of 1.07 and then you divide by 8.23, so you are going to get 7.84. So the critical or calculated value now is 7.84. So to check our table value, so we have what we call degree of freedom. So the degree of freedom is n1 plus n2 minus 2. And if you do that, you are going to get 23. So we are going to check the table value, that is at 0.05 significant level. So check, if you look at our 4-figure table, so we have the value on the top of table, you have 0.05, check 0.05 under the 123. So you can't see 123, so what you see is 30 and above. So if you check that, you are going to get 1.96, and that is our table value. So we are now going to take our decision. So we are now going to see that since the calculated value 7.84 is greater than the table value, that means that which is 1.90, that means that the significant difference in the mean performance of the two sets of students. Chi-square is a non-parametric inferential statistics method that is used in analyzing the frequency or nominal data. These tests allow us to determine whether or not a significant difference exists between the observed frequency of cases in each category of variable studies versus the expected frequency. The observed frequencies is the data that is obtained from the actual frequency count, while the expected frequency is the data that will be obtained if equal number responded to the same variable equally. To calculate chi-square, we make use of the formula summation open bracket O minus E close bracket square all over E, where our O is the observed frequency, while our E is expected frequency in each cell. So let's look at the given example. In this example, we are to determine whether the interest of students towards mathematics is gender based. So if you look at the outcome of the research, we have male that said yes is 41, while 9 male said no. 39 females said yes, while 11 females said no. To calculate the given example, so we are going to determine the expected frequency. So, and to determine the expected frequency, we are going to use the formula FR times FC all over N, where our FR is total row frequency and our FC is total Coulomb frequency divided by N, and our N is total frequency. So the first thing we are going to do is to determine the total row frequency for the male and female, and the total Coulomb frequency for yes and no. So the total row frequency for male is 41 plus 9, which is 50, and the total row frequency for female is 39 plus 11, which is also 50. So the total Coulomb frequency for yes is 41 plus 39, which gives us 80, and the total Coulomb for no is 9 plus 11, which will give us 20. So if you add 80 plus 20, or you say 50 plus 50, you must get the same thing, which is still 100. So the next thing, we find the expected frequency for yes and the expected frequency for no. So for the row 1, cell 1, so the total row is 50, while the total Coulomb is 80. So now say 50 times 80 divided by 100, and that gives us 40. So we are going to put 40 in row 1, cell 1. For row 1, cell 2, so the total row here is still 40, while the total Coulomb is 20. So we now say 50 times 20 divided by 100, and that gives us 10. So we are going to write 10 in row 1, cell 2. So for row 2, cell 1, so the total Coulomb here is 50, while the total row here is 80. So we now say 50 times 80 divided by 100 will still give us 40. So we write 40 in row 2, cell 1. So for row 2, cell 2, so the total row here is 50, while the total Coulomb is 20. Now say divided by 2, 100, and that's to give us 10. So we are going to write 10 in row 2, cell 2. So the next thing is I'm going to calculate the chi-square, which is a summation of observed minus expected square all over expected. So the observed here for the first one is 41, and expected is a 40. You now say 41 minus 40 all over 40. So 41 minus 40 will be squared all over 40. Then the second one is a 9 minus 10 squared all over 10. The next one is 39 minus 40 squared all over 40. The next one is a 11 minus 10 squared all over 10. And then we now continue to solve that. We have 41 minus 40 squared. That gives us minus 1 squared over 40. Then plus 9 minus 10 squared gives us minus 1 squared all over 10. Plus 39 minus 40 squared will give us minus 1 square over 40, plus 11 minus 10 square will give us 1 square all over 10. So when you say 1 square is same thing as 1 over 40, plus minus 1 times minus 1 will give us minus 1, that will give us 1 over 10, plus minus 1 square is 1 over 40, plus 1 square will also give us 1 over 10. So if you divide 40 by 1, that gives us 0.025, plus if you divide 1 by 10, so we are going to get 0.1, plus if you divide 1 by 40, you are going to get 0.025, plus if you divide 1 by 10, you are going to get 0.1. So if you now add 0.025 plus 0.1 plus 0.025 plus 0.1, and that should give us 0.25. So the next is to find the degree of freedom, and the formula for degree of freedom is rho minus 1 in bracket then colon minus 1. So the role we have here is 2 and the colon is 2. So we are going to say 2 minus 1 will give us 1, and 2 minus 1 will also give us. So 1 times 1 will be 1. So our degree of freedom in this case is 1. So now we are going to use the degree of freedom with 0.05 significance level to determine the table value. So if you check the chi-squared table, we are going to check 1 under 0.05, and if you check that, our answer is going to be 3.84. Now we are going to compare now. The calculated value we got the other time was 0.25, and the table value here is 3.84. So we are going to take decision using the 2 now. So we are going to say, since the critical value exceeds the calculated value, then we are going to conclude that the interest of students towards mathematics learning is not significantly dependent on gender.